Mr. Thomas live on the air. I'm going to go over quiz number 1. This is from Math 142 Trigonometry. So let's just get started. I'm going to try to get as far as I can. If I have to take a break, I'll stop and take a break. So let's just get started. Number 1, it says, find a positive and negative coterminal angle for pi over 6 in radians. Okay, so if you actually wanted to make a quick sketch, you could quickly just convert pi over 6 into degrees. Let pi be 180. We'd get 180 over 6 is 30. So we actually know that pi over 6 terminates approximately right there. This is my xy plane, and this is about 30 degrees. But coterminal means that give another angle that will actually end right here. And so the way to do that, to get a positive one, we take pi over 6 and add 2 pi to it. We complete one full revolution. And let's calculate that real quick. If we have pi over 6 plus 2 pi, we get pi over 6 plus 12 pi over 6. And now we can just add them together. We get 13 pi over 6, and that's the positive one. To get the negative answer, we would take pi over 6, and then we can also subtract 2 pi this time. We'll go the clockwise way around, and that's equal to, we get pi over 6 minus 12 pi over 6 again, okay, and we're left with just negative 11 pi over 6. And so now the answers are in radians, and that's what you needed to have. The problem said find 2 positive and negative coterminal angles for pi over 6 in radians, and so there you have it. 2, it says a giant redwood tree casts a shadow of 160 feet. So if we have a tree here, the shadow would actually be 160 feet. And then it says find the height of the tree. So we'll call the height be x. We'll let the height be x as we do not know. And then the elevation of the sun from the ground. So that elevation, that angle of that sun that forms the shadow, gives us a 30-degree angle right there. So now we basically have a right triangle, and we must use this angle, the opposite side of the angle, and then the adjacent side. The only trig function that does that is either tangent or actually cotangent. But we're going to use tangent of 30 degrees is equal to x over 160. And so 160 times the tangent of 30 degrees will give us the answer. I'm going to pull out my calculator really quickly. It's always good to double check to see if your calculator is in degree mode, and then punch in 160 times the tangent of 30. And that's reported an answer of 92.38. It's the directions were to round to the nearest hundredth or more, so it was actually 376, but I rounded to the nearest hundredth. So 92.38 is the final answer. Okay, the next question. It says if sine theta is 2/3, then find the other 5 trig ratios. So if sine theta is, oh, here we go. My sine theta is 2/3, so I can immediately find cosecant theta because I know it's the inverse. It's 1 over sine theta, so 1 over 2/3 is actually going to just be 3/2. Next, I'm going to need to find the cosine theta, and I'll find secant theta, and then also I have to find tangent theta and cotangent theta. In order for me to actually find the rest, I'm going to need to, uh, I need to know the sides of all of my, uh, the sides of all of the triangle, my right triangle there. So I know that since it's given that sine theta is 2 over 3, I know that the opposite side of theta is 2, and the hypotenuse is 3. And so now I actually need to find this side here. This is the unknown side. So basically, I need to solve for x, and I know that x squared plus 2 squared is 3 squared. So that's x squared plus 4 is equal to 9. That's x squared equals 5. So x is root 5, and so that's just great. Now we know that x is root 5, and so the cosine theta is actually going to just be root 5 over 3. Secant theta would be 3 over root 5, and then tangent is 2 over root 5, and the cotangent is root 5 over 2. All right, let's move on. Now, by the way, it must be stated that the radicals are in the denominator, and so to get rid of that, you could rationalize the denominators there for secant and for tangent, and the equivalent form would then be 3 root 5 over 5, and also here we get 2 root 5 over 5, because if you just multiply the top and bottom by root 5, you get it. Number 4, it says express tangent theta in terms of sine theta, where theta is in quadrant 2. So what we do know is that tangent theta is actually equal to sine theta over cosine theta. And so basically, if we can change cosine theta in terms of sine, then we could write tangent in terms of sine. So what we need to utilize is the fact that cosine squared theta plus sine squared theta is equal to 1. So cosine squared theta is equal to 1 minus sine squared theta. And cosine theta is equal to the square root of 1 minus sine squared theta. And that's plus or minus. When you take the square root of a variable, which happens to be cosine theta, you do get plus or minus. And so you move the plus or minus over there. And so basically we can write tangent over sine over the cosine. Now we know cosine can be written in terms of sine, and we have a choice. We can either use the positive root 1 minus sine squared theta or negative root 1 minus sine squared theta. Now, since theta is in quadrant 2, tangent must be negative, and so basically we get is sine theta over the negative root 1 minus sine squared theta. And that's our final answer there. So again, I can pull my negative out front and have sine theta over the square root of 1 minus sine squared theta. And that is enough there. That is the final answer. 5, it says find the reference angle for negative 199. And so just a quick picture of that. If you're going negative, we're going clockwise. And if I go from here to here, that's already 180. And another 19 past that is 19 degrees there. And so the reference angle is actually going to be positive 19. So the reference angle of theta is actually going to be positive 19. It terminates right there at just past. So this angle actually, let me just put in from here to here is basically negative 199 degrees. And we know that the reference angle is that angle that you actually form a right triangle with the x-axis. So that distance there is just 19. All right, let's move on. Not much left. We have the cosine of negative theta, or negative 30 degrees. It turns out, since cosine is an even function, the cosine of 30 degrees, of negative 30 degrees, is still the cosine of 30 degrees, which is just the square root of 3 over 2. And here we have another one. Find the quadrant in which theta lies in. So it's either quadrant 1, 2, 3, or 4. But they tell us that cosecant or sine is greater than 0. So we know sine is greater than 0 at 1 and 2. Cosine theta is negative. So cosine is positive in 1 but negative in 2. So by default, it must be quadrant 2. Let's move on. The sine inverse, the inverse of sine, is the angle whose sine is a half, and it turns out um, the angle whose sine is a half is 30 degrees. So we're talking about a 30-degree angle, and we actually now have to calculate the tangent of 30 degrees. Now, the tangent of 30 degrees is actually opposite over adjacent. And if you rationalize that, you actually get root 3 over 3 for the final answer. And now I will jump on down to number 10. It turns out 9 cannot be done. So it does not exist. We cannot solve anything there. So we're going to move on to find the largest angle there. So if I have a triangle and I have 9, 13, and 20, this angle opposite the 20 will actually be the largest angle. And so I have to use the law of cosines there. So it's 20 squared is equal to 9 squared plus 13 squared. 9 is 2 times 9 times 13, and then the cosine of theta. And I need to just simplify that out. So I know that 400 is equal to 81 plus 169 minus 18 times 13 times the cosine of theta. And if I keep computing this out, I get, well, 81 plus 169 is 250. So I get 400 is equal to 250 minus 234. And now I need to solve for the cosine. I need to subtract 250 from both sides. I'm actually going to be left with 150 is equal to negative 234 cosine theta. So cosine theta is actually going to be equal to 150 over a negative 234. And in order to actually find theta, I have to take the cosine inverse of both sides. So theta is actually going to be equal to the cosine inverse of negative 150 over 234. So I can compute that really easily. Negative 150 divided by 234. I got theta to be 129.87. And the only thing left to do is actually find the area of the triangle. And we can use Heron's formula, which says first calculate the semi-perimeter. So we actually add up the sides and divide by 2. If we add up all the sides, we get 9 and 13 is 22 plus 20 is 42. So half of 42 is 21. And now we're going to use Heron's formula. We get the square root of s times, let's see here, we get so 21 times 21 minus 20 times 21 minus 13 times 21 minus 9. And that's going to give us the area. So let's just keep calculating that. So I'm actually going to get 21 times 1 times, well, what's 21 minus 13? I believe that's 8. And then 21 minus 9 is 12. And now let's just keep calculating this. We get 21 times 96. All right. So I'm getting the square root of 2016, and the square root of 2016 is approximately 44.89. I hope this was helpful. I will spend more time talking about the law of sines. This problem was a law of sines problem, but it turned out that there is no triangle to satisfy that equation. But this is all the time we have for today, and I will be in touch. Take care. Bye-bye.